We are looking at continuity and one-sided limits here at gotomath.com, and we're in this section right here. So let's scroll down and see what we got. We've got a piecewise function, and of course this is not the traditional way that you would write that, but this is the way I wrote it. And we'll go to the whiteboard and explain it here in a minute. We have f of x equal to x. However, x cannot equal 10. So all real numbers except 10 in the domain, and then we have f of x is equal to 6 when x is equal to 10. We've got the limit as x approaches 10 coming in from the right hand side of f of x. So let's move over and write all this out. I guess we'll use blue. So we have f of x. Of course, this is going to be the more traditional way that you would normally see this. Big curly bracket. We have x, and this means that we can use everything except 10 for this, and then 6, and the only thing we can use, whoops, I didn't mean to write a 6 there, I meant to write a 10. And we're asked to find the limit as x approaches 10 from the right hand side of f of x. From the right hand side. So which one are we going to use? We're going to use this one, or we're going to use this one? Well, let's kind of sketch out a picture over here so you can see what's going on. And we'll go back and use blue. So let's graph this out, this part. What is the graph of f of x equals to x? Well, that's just a line, right, running through the origin. And I guess we should note, let's put 10 right here on the x-axis. And we're going to put a hole right here because it says we can't use 10, so let's put a hole there. And so this is what it looks like. Alright, that would be this part. Now this is just a constant, which is running across at 6, but it says we can only use 10. Can't use any numbers but 10. So that's going to be a solid dot somewhere about right here, let's say. Of course, not to scale. Alright, and we'll say this is 6. Yeah, definitely not to scale. Should be probably a little more. Alright, so there's our graph. Now we're asked to find this here. So we're coming in from 10 from this side, the right hand side. And that means that when we take numbers and we plug it in, right, as you can see, we're actually moving along the graph up here. Okay, we're moving along the graph. And what did we say that this was approaching? We plug 10 in, we get 10, or I shouldn't actually, we don't get anything because it's not defined at 10, but I'm just going to tell you where this dot's at. How's that? This hole. Alright, so we come in and we are approaching, as we get closer and closer to 10 from the right hand side, our y value is approaching that hole, which is actually at 10. Alright, I hope that makes sense. Hopefully. Okay. Alrighty. Oh, let's see. Since we're in continuity, the question is, let's ask the question, where is this graph not continuous? Well, it's not continuous here. Okay, it's not continuous here. And of course, this is the case we hadn't run across, but we'll have to hurry. We have f of, we're evaluating it. First off, f of 10 is actually 6, and that's where this comes from down here. And the limit as x approaches 10 of f of x is actually 10, but you notice these two numbers must be the same, and they're not. Therefore, it's not continuous at 10.